next lesson, we are going to be talking about linear regression. So when we say linear regression, we're going to be referring to scatter plots, which are graphs that relate to two different sets of data by plotting them as ordered pairs. Okay. Now we can also talk about correlation, and you are going to talk more about this if you take AP Stats or if you take a stats class in college. So we have different kinds of correlation. So if I just make a graph here and I put a bunch of points on here, we want to look at which way the data is trending. So looking at this, I have a positive correlation because it's going up. Okay. Now let's say that I have that same thing, but I put my data appears to be a little bit closer together. So something like this. This is still a positive correlation, but it's a lot stronger. So we would say that this is a strong positive, whereas this one is a weak positive because the data is a little bit more spread out. Okay. On the other hand, I could have something that looks like this, or something like this, where again the points are a little bit tighter. Okay. So because they're both sloping down, we would say that this is a negative correlation for both of these. And then the ones that are closer together, we would consider this a strong correlation, and then this one would be a weak correlation. And the last type of correlation that we could see is something that looks like this, where there doesn't seem to be any type of slope happening. So this one would be no correlation. Now, as you get into this subject, they have, again, classes dedicated to the study of this. You'll be using your calculators a lot and calculating the R value, which gives us a better indication of how strong, weak, or no correlation there is of data. And we also have to remember that correlation doesn't mean causation. So those are two very different ideas. Okay. Now for this class, we're going to really just be looking at the data, and we want to use this idea of a trend line, also called the line of best fit, or we sometimes refer to it as a regression line. So this is a line that closely approximates the data. So basically, we're putting a line right through the center and calling that our trend line. Okay, so same thing that we would have a trend line. This would be about our trend line. And we can calculate these by hand. We can calculate them on the calculator. Sometimes we might already be given them to us. So for the purposes of this class and talking about linear equations, we're going to be focusing on that trend line. Okay. So in our example problem, and this, I took this right out of ALEKS, so you're going to see a topic similar to this when you start working on that homework. It says the scatter plot shows the time spent watching TV, X. Okay, so here this is the time spent watching TV, and the time spent doing homework, Y, by each of 23 students last week. Okay, so again, here's the time spent watching TV, which is the X. So if you need to, if you have this on paper, if it helps, you can write that this is the X information, and then time spent doing homework is Y. Okay. Now they are giving us our line of best fit, so here's our equation for it, and we would expect our slope to be negative because this is trending down. And then we're just going to use that to answer our questions below. So the first question, what is the predicted time spent doing homework for a student who spends 12 hours watching TV? So time spent doing homework is a Y. So again, if it helps you, we can label that. And then time spent watching TV is X. So they are giving us an X value basically and asking us to find the Y value. So I'm just going to plug this into that X in the equation. So this will be Y equals negative 0.82 times 12 plus 25.87. So I'm going to grab my calculator and I'm just going to type that in. So negative 0.82 times 12 plus 25.87. Okay. And my calculator is a little hard to see, so let me see if I can fix that for you guys. Okay, it's a little better. Okay, so my answer for this is going to be 15.67, and then on my label would be hours. The next question, it's asking, what is the predicted time spent doing homework for a student who doesn't spend any time watching TV? So again, doing homework is the Y, time on the TV is X, and if I'm not watching any TV, that means I would have spent 0 hours doing that. So that means that we're substituting 0 in for the X. So Y equals negative 0.82 times 0 plus 25.87. So that just means that my answer for this would be 25.87, and again, my label will be hours. And let's see, the last question. For an increase of 1 hour in the time spent watching TV, what is the predicted decrease in the time spent doing homework? Okay. So basically, since we're comparing, it's asking us to compare the hours that we're watching TV to our hours doing homework. This is another way of asking you what the slope is. Oops. Okay. Now, because it's already using the word decrease, when I write the slope, I need to make sure that it's the positive version, because the decrease would account for the negative that we have here. So our answer to this would be 0.82. And if you want to, we can circle our answers to identify that we are done with that. Okay. All right, so next one. So we have a scatter plot that shows the number of hours worked compared to the money spent on entertainment. So my graph is on the next page here. So what I would like you guys to do is pause the video and then go ahead and answer those questions. All right, so looking at question A, it says, what is the predicted amount of money spent on entertainment for a student who works 10 hours? So again, that just means that I'm plugging in 10 for either the X or Y value, depending on what we are talking about. So number of hours worked is X, and then money spent on entertainment is Y. So that means if this is for a student who works, I have to plug the 10 in for the X. So this will be Y equals 1.76 times 10 plus 11.07. So again, I'm just going to type that into my calculator and simplify it to get my final answer for this problem. So it should be 28.67. And then my label for that would be, money, so a dollar sign. Okay. All right, next, what is the predicted amount of money spent on entertainment for a student who doesn't work any hours? So again, I'm just plugging in 0 for the X. So instead of writing that out this time, if I'm substituting in 0 right here, that's just going to cancel this term out, and my answer would be 11.07. And again, we're talking about money, so my label would be dollars. For an increase of 1 hour in time worked, what is the predicted increase in the amount of money spent on entertainment? So again, when it's asking what is the increase of 1 hour compared to the increase of the money, this is just another way of referring to slope. So I'm just stating what that slope is. So looking up here at my equation, my slope would be 1.76 for the answer. All right, last question. So this one, again, we're still using that line of best fit, but our questions are going to be a little bit different this time. Okay. All right, so on our next question, it says the scatter plot shows the weight and fuel efficiency for each of 25 vehicles. Also shown is the line of best fit for the data. fill in the blanks below. So this time we're not given an equation. Okay. Says for these 25 vehicles, as weight increases, fuel efficiency tends to what? So as I'm looking at this, so as weight increases, so as we go this way on the chart, the fuel efficiency is going down. So I'm going to put decrease. For these 25 vehicles, there is blank correlation between weight and fuel efficiency. So again, because we are decreasing, that means that there is a negative correlation. And the last question, using the line of best fit, we would predict that a vehicle weighing 3,000 pounds would have a fuel efficiency of approximately blank miles per gallon. So that means I'm using my chart and I'm kind of making my best guess. Okay, so again, looking at this, we would predict that a vehicle weighing 3,000 pounds, so here's my 3,000. So I'm just going to follow this up until I hit that line of best fit, so that's here. And then my Y value at that point would be 30, so it would be approximately 30 miles per gallon. All right, one more question like that, and then we are going to be done with this section. All right, so I would like you guys to pause the video and then go ahead and answer the next 3 questions. All right, so the scatter plot shows years of experience and hourly rate for 25 cashiers in New York. Also shown as a line of best fit, fill in the blanks below. For these 25 cashiers, as experience increases, pay tends to increase as well. There is a blank correlation between experience and pay. So this is going to be positive since we're going up. And then lastly, use a line of best fit. We would predict that a cashier with 9 years, so here's my 9 years, would make approximately how many dollars per hour? So going up to my line here. So I'm not on a nice spot. So again, I'm just kind of using my best guess. So somewhere between 16 and 17, but I'm not quite halfway through. So I'm just going to approximate 16.25. So $16.25 per hour. So as long as you had somewhere close to that, that would be an acceptable answer. Okay. And that is also going to conclude section 5.